Alright, so based on the function Dup2, which of the following asymptotic bounds apply in each case? So given the fact that the best case for Dup2 is theta 1, we know that theta 1 it's not less than, but it is equal to O of 1. Thus, that case applies. So that's good. We also know that theta 1 is less than big O of n. So that case is also true. And we also know that theta 1 is less than big O n squared. So that case applies as well. Now, when it comes to big omega of 1, we know that theta 1 is equivalent to that. And we also know that theta 1 is not greater than or equal to omega of n, nor n squared. So those two do not apply. Now, when analyzing the worst case, we see that Dup2 has theta n order of growth. So given that, we can see that worst case O of 1 does not apply because theta n is not less than or equal to O of 1. However, when we come to O of n, we know that theta n is equivalent to that. Thus that case applies. And we also see that big O of n squared applies as well, because big O of n squared is greater than theta n. So those two cases apply. And because O of n best case and worst case both apply, that would also become the overall. And O of n squared best case and worst case both apply as well, so those count as overall as well. Now, when it comes to analyzing worst case for big omega, we can see that big omega of 1 is less than theta n. So this is true. And when we look at big omega of n, that is about equivalent to theta n. So that case applies. However, big omega of n squared is not less than or equal to theta n. Thus, that case does not apply. And then when we go back to look at big omega of 1, we see that's true for best case and worst case. Thus, that would apply overall as well.